Also, let's wait additional couple of seconds and kick it off. Well, I think let's go. So please ping me. Hope you can hear me and see me. Thanks. So today I want to talk about two things. The first one is the way how the modern world crafts, designs, and implements regulation around AI and how it impacts us right now. It's not the matter of next 10 years. It starts to be important for us even this year. And the second one, the synthetic data approach. Back to the beginning, I'm Sergey Kuprienko. I am General Manager of Research in Squad. We are the biggest research and delivery center of one of the biggest companies in the world. Here we are. Well, I think the best idea is if we will have two blocks. So I'll touch regulation first, then we will have a quick questions block, then the synthetic data, and we will have 10 minutes for the every single convenient, inconvenient, or funny questions you have. So one by one. Artificial intelligence and regulation. A couple of weeks ago, European Union released issued the first draft of the document called the High Risk AI Regulation. This is a pretty interesting document. I didn't read it the whole one because it's 652, as far as I remember, pages, and it's amazing doc. But the key outcomes from that one. There are two sections. The first one describes what is high risk AI, and the second one describes how we should manage that. The first one calls, high risk AI. This is basically the AI that may expose high risk to us, like biometric identification, categorization, critical and life critical, mission critical infrastructure, management or operation, education and training, employment, workers management, self-employment assessment, and assessment to kind of private services and public services and benefits. Basically, it means that every single interesting area of artificial intelligence or machine learning application, you can design something that will have an impact, is covered and is called high risk AI right now. Welcome to this brand new world. So, what should we do with this? And despite this is a very first draft, this is the direction we move to as an industry and in the way how we will collaborate and find the new balance between the regulation, governments, and the AI industry. 6 topics, I will touch them briefly and then focus on the most important one. The first, surprise, surprise, is data and data governance. There is 10 pages around it. It should be, data should be complete, relevant, representative, free of errors, and unbiased. The second one is the technical documentation. Again, surprise, and the best thing we should have as researchers, as engineers, is to have the documents for everything. How does it work? How does it work? How does it make the decisions? And what kind of risks are there? Record keeping. It's not about having records, it's about the complete and explicit logging subsystem. That everything that is deployed to production and the way how AI works should be logged. So first of all, we should be able to investigate any specific or particular case if something bad has been happened, and have access to logs so we can check them by a human in the loop or by another AI. Transparency means that high-risk systems should be totally covered by instructions for use. The instructions should be clear. Everything label that's where AI can impact our life in terms of high-risk AI should be labeled. This decision has been made by AI. You have been warned, use it or run out of it. And the human oversight. So high-risk AI systems must allow some sort of a system that allows the human or the person to fully understand the capabilities, the limitations, and monitor if something for any kind of signs of dysfunction or malfunction. Ultimately, we should have a red big stop button to switch everything off. How it impacts us and how should we work with this as an industry, even right now. And I know that we have a different like set and directions of people here, and so for the next couple of years, it means that explainability is not a buzzword anymore. That's something that we should put as a like the keystone for our systems, because again, as soon as we do something funny, it's not an issue for us. But this is not the area that we can have a lot of impact or create systems, the AI systems that make a difference in this world or improve the lives of the people. And for all systems that make a difference, we should keep it clear. We should keep it explainable. At least we should move in this direction, because it's not something that we can do for just on a clip of the eye. And the second approach is logging. It should be done by everything. So AI, and based on machine learning, based on the way how it operates, it will do the mistakes. So we have to be able to track them. We have to be able to investigate the corner cases and to explain why they happen, so we can get back to the system. First of all, we should protect ourselves from any kind of lawsuits, because we're industry and we don't want to screw up the whole company for the one corner case. On the other hand, we should be ultimately protecting our customers. It means it should be tracked. It should be clear again. And coming back to the way, how do we think about it? It should be just ultimately safe. In terms of, again, the impact and having a step back, on the one hand, we think that high risk is something that manage some medical or transportation systems, or like autopilot systems, or surgery, whatever else. It's not, because everything that touches biometric data, everything that touches any kind of individual characteristics like AD targeting, like one scoring, like whatever else, is a high risk AI, and it will be basically it is right now. We just don't like call it in the world right now by high risk AI. So it's a pretty wide set of the applications, and we even don't touch any kind of the industrial robotics or any kind of supporter robotics for us. And to this point, it means when we design systems, we should think about it, how they will be deployed, how they will be operate. And again, talking from the high level perspective, it should be completely safe and unbiased. The one important thing here that we should think about from the very beginning is the risk management system, because when some issue happens, except the issue itself, the way how you will be treated depends on there is a totally different story, and there is a big difference between the issue happens. This is the risk management system. This is how it works. This is our reaction plan, and this is our recovery plan. So we just have everything in place. It just works. So let's initiate this inconvenient, sad, but this is the procedure for them. And the other story is, wow, something happened. We don't know what to do, and we just don't have anything about risks. Totally different story and a totally different outcome for the company. Do you work for, you own, you founded, or you work with? I put a small, like 5 seconds gap here. Do you have any points, questions, or feedback to this point? Because I want to link to the data, and that's the next step and the next step of experience. Okay, I do believe everything is clear. And the next story, and let's get back to the very first key requirement for high-risk AI, and that matches to the hype we have for the last 2 or 3 years. That's data. So the question number 2 in the high-risk AI is data, and then the governance. Again, it should be free of errors, already complete, free of biases, and contains all the geographical, behavioral, whatever else distribution that is can be considered as critical. So synthetic data. For the last couple of years, we work a lot, and we have a lot of startups around the synthetic data. NVIDIA did a huge improvement on this because it's a critical business for them to sell over the cards. But still, it's something that that's on the edge. On the one hand, we just started to use it on a scale. On the other hand, sometimes it's still more a toy or just a good intention than something we are ready to use in production. So from the experience we have and from the way we use it, for the data, we always struggle with 2 different things. The first one is the domain gap, and this answers us a question: is it good enough, or not yet? Like, how close it to real data? It's all about from the pictures, images, or videos we use for CV to any kind of the data or time series data we use for scoring systems, we use for decision-making systems, for whatever else. And again, from the experience, it's not the issue of the eliminating domain gap. We don't. It's a running target. We will always fail to do this because the costs will become prohibitive. But the data should be synthetic data should be just good enough. Set some numbers, start from some thresholds, start from some KPIs, and then improve the generation, subsystem, infrastructure, whatever you use there, to the point where it's just good enough, and then take it from there. Because focusing on the eliminated domain gap will take us forever. The second big direction, is the biases. So on the one hand, working with synthetic data, we fall into the trap of the wow. Now we can manage biases. Basically, why now we can press set and we can program them. Well, so before that, I just had some set of data, and this is the data I live with ultimately. So this is what I can collect. This is what has been collected, and let's just dig into it and try to annotate them, try to work with this. Right now, you see there are thousands of small knobs, thousands of small sliders, and you can generate everything. But the question is, what should be generated, and what is the appropriate set of the parameters for that? The same story here. So start from something you have with any kind of real data set, add there the key measurements and the key numbers that will track the most important biases, the most important possible biases for you, the most important dimensions of the diversity, and take it from there. And then improve it, and always track. One interesting perspective or point that is different between the real data and the synthetic data is how it evolves in time. For instance, when we work with real data, we have some solution, and then after that we deploy the solution, and we have the process in time, like some kind of the CI, whatever else, continuous improvement process. It means we collect another set of fresh data, check how it works, and probably retrain something and put it back to prod. For synthetic data, that's a bit different because we at least frequently forgot about this. So the way key point here, how the data how it's changed, especially like for classical example about the loan scoring system. When you deploy your AI based solution, which is perfectly balanced, free of any kind of biases, and works just well, and gives you $10 million per of annual savings. But after that, the nature of the decisions has been changed. So the new set of the data collected after this deployment will be different, different biases, different trends, different stories. You have your customers have been changed, their behaviors have been changed. Coronavirus happened, I don't know. So this should be tracked, and your generator should be adjusted to this new set of data. And that's probably the most complicated part of the loop, like to make the decision what should be adjusted and what should be okay. What's the balance between the previously generated set and the new one? Should we replace them? Should we extend it? And what's the new reality? And the same for domain gap, the same for logging. So one of the interesting things for the synthetic data that allows us to work on biases and to work on the small insights there is, we not only can create or generate the corner cases for us, having a huge amount of data, we can discover the corner cases in the places we were blind for before. This is it. So coming back to the grand summary to give us a couple of minutes for the Q&A session. So the way how we work with the high-risk AI and AI in total in the next couple of years will be not fundamentally changed, but adjusted a bit. So we will add a lot of things about logging. We will add about a lot of things about issue investigation and explainability. So talking about the next big direction, if you want to jump in the like next 10, 15 years AI world, this is the pretty hot topic, and it just begins to roll out. And one of the key points is still a data for that. And the data, the synthetic data is on the one hand is promising and still it's still the beginning of the journey. On the other hand, we can use it right now. We should use it right now and just do it. From our experience, works pretty well, but requires a decent amount of the efforts to work with the domain gap and to work with the bias there. I said that's all, and please feel free to. Oh, I just perfectly fit to 20 minutes here. So please ping with me with the questions. We'll be happy to answer that. Oh, that's a sun. I'm just starting to figure out, have I switched on my microphone at the beginning? Or what?
Hey, thank you.
Yeah, you're welcome.
Yes. If there is no question, I will stop the meeting. I think Ostap wrote the question, as you can see in the chat.
Yes, thanks. Ostap, that's an interesting topic. I'm being a part of and attending the KAHAI committee, this European Council ad hoc Artificial Intelligence Committee. The discussion started, like, as far as I remember, probably 2 years ago. But that's the answer is pretty straightforward. This is the way how our bureaucracy works. It took them 2 years to build the 600 pages document, and this is where we are right now. So this is it. And this is the way how should we craft this, the reply or response to this from the industrial level, and we do this right now. Every single big company writes its own document, and that all will be put together, and that will be the next step of discussion. So not just to say no, that's a bad idea, but from the perspective of, okay, that's our new future, and this is clear, and standing on the customer's side, how do engineers want to propose their approach to this? But to this question, the answer is pretty simple. That's just how it works. It's 2 years.
Okay, if there is no questions, I think we can finish. Thank you, Sergey, once again.
Thanks a lot.
Yes. Goodbye.